which is actually a nastier question. You're like, well, I could just do this and then set x equal to the x part and y equal to the y part and z equal to the z part. And then I just know that s and t aren't invited to the party, so I'll eliminate them using this thing called algebra. That is true. Some of you have sufficient skill to do that successfully, but you're wasting your time. There's a better way. Although I do love algebra. I won't deny it. 2. So find Cartesian equation of plane. Now we need 3 points. Let's say p is equal to 1, 1, 1. Let's say that q is equal to 7, 5, minus 3. Let's say that r is equal to 3, 2, 1. We want to find the equation of the plane containing these 3 points. Cartesian equation, okay? How do you do it? Well, here's my go-to method. I basically draw the picture I was just drawing before, all right? And I choose one of them as a base point. P looks pretty nice for a base point here. So I think P as being my base point. And then I just imagine Q being here and R being here. And I try to calculate these tangent vectors that lie in the plane. Of course, the displacement vectors from one point to the other, they have to be tangent vectors. They have to be vectors which lie in the plane. So, for example, PQ is what? Q minus P, right? So Q minus P is what? 6, 4, minus 4, right? And what is, what's PR? R minus P, right? That's how it goes. So what's that? That's 2, 1, 0, right? I usually call these A and B because I get sick of writing PQ and PR, but you can call them whatever you want. Now, we know to write the Cartesian equation for the plane, all we really need is what? Love? No, not love. It's not the answer to everything. Although if you don't have love for what we're doing, it does make it less enjoyable. That is true. I know. I've taken some classes for which I had no love. I feel your pain. We're looking for, this is the way to do it, right? Sorry, equal to 0, right? We need the normal. Exactly. Last time we talked about the cross product is a way to get a vector which is perpendicular to 2 given vectors. In 3 dimensions, you got a vector, you got another vector. The perpendicular is only one way, right? The perpendicular has to be, the normal has to be the cross product if you just think about it geometrically. It's inevitable, right? There's only that 3rd dimension. It has to be the same as the cross product. So yeah, that's what we do. Ah! I know. So it should be something like these. Let's see here. Oh, I guess that's going to be, in terms of my picture, that's B cross A. See, right-hand rule, B cross A, up. But it doesn't really matter in terms of the equation. If you do A cross B instead of B cross A, it just multiplies your equation by a minus. So you can't really go wrong there unless you're trying to match it up with a picture. Although I guess, again, it does kind of matter which is up and which is down if you're like building a building or something. But as far as equations are concerned, whatever. So here we go. B cross A. What is that? Let's see here. So we're going to calculate the determinant of x hat, y hat, z hat, 6, 4, minus 4, 2, 1, 0. That gives me 4, minus 8, I think. 8. 4 minus 8 minus a 2. Now, this is a cross product. I don't trust myself to calculate cross products. I will check my answer now. Dot product of the cross product in A. 4 times 6 is 24. 24 minus 32 is minus 8. Minus 8 plus 8 is 0. Okay, A dot this, 0. Good. This gives me 8 minus 8, 0. So if you calculate the dot product of this and this with that, you get 0 both cases. We're good. Yes?
How do you know which order the product is in that condition? So like you put A vector first, and then a vector.
Oh, no. Your question is very good. I forgot to put a minus here. You're right. I just calculated A cross B. I'm sorry. Yeah. You know, it's good equipment, but there's always operator error. Okay, so with that unfortunate sign happening, what's my equation? Thank you for that question. That was an excellent question. So let's use P as our base point, right? So we got 4 times x minus 1 minus 8 times x minus 1 minus 2 times x minus 1 is equal to 0. Now, if I don't want to be a jerk to the grader, right, and if the problem doesn't have a base point which suggests itself, the decent thing to do is to ask you guys to give your answer in the pointless form. Because the pointless form is unique up to like a scalar multiple, you know. So if I rewrite this in the pointless form, it's 4x minus 8x minus 2x is equal to... No. What's that? Oh, yeah, I'll do that. Oh, I did it twice, too. I'm consistent. Goodness gracious. What on earth is wrong with me? Oh, okay, yeah, that's it. 4, I'll take that. 4 minus 8 minus 2. Yeah, it's amazing I'm still thinking at all at this point. Minus 8. Although it should make for a more amusing semester for you guys. I'll make some truly hideous errors this semester. I'm not even tired yet this week. Wait till I get tired. It'll get worse. But it's okay. There are people in here who are paying attention and they're correcting me. So the rest of you will be okay. Unless those people don't come to class, in which case you're stuck. I mean, it's game over. Okay, yes?
4 minus 8 minus 2
What was I saying? Well, I was true to my comment. Let's see here. Gosh. What if you wanted to find the point on this plane which was closest to a point off the plane? How would you do it? Let me pick a specific point to make that question interesting. So I take this example and raise you another example. Let us take the point 7, 8, 9. I would like to find, let me call this point Bob. So how far is Bob from the plane is the question. By definition, what do we mean distance from a point to an extended object? Smallest distance. That's the definition. You're like, well, you just take an arbitrary point on the plane, you write a function of several variables, and then you minimize that function, right? That's what we do in about a month. But even then, we shouldn't do it because there's a geometric solution to this. It is clear that if you drop a line down to here, right? Then if you think about the line which is in the normal direction, there's two pieces, right? There's the, whatever this thing is, let me call it, I need a name. Joe. Okay, Joe. The Joe vector. There is Joe on the plane, and then there's Joe normal, right? And the length of Joe is absolutely the smallest when you can make the Joe plane go to 0, right? I mean, so you want Joe to line up with the normal. We want Joe to be normal. Seems good. So what's the equation of the normal line? N of t is equal to, what's a point on the normal line? Here's the normal line. We know one point on the normal line, this one. So we do 7, 8, 9 plus t times what? What's the vector, what's the direction of the normal line? The normal to the plane, right? So it's 4 minus 8 minus 2. Right? So the parameterization for the normal line to this plane is 7 plus 4t. Indeed, 8 minus 8t, 9 minus 2t, right? That's the parameterization of the normal line. How do I figure out where that line intersects the plane? How do you figure out where two graphs intersect in the plane? What do? You set their formulas both true, right? You combine the equations. What that means in our current context is you feed the parametric equations for the normal line into the equation for the plane. In other words, this is x, this is y, this is z, and so we do 4 times 7 plus 4t minus 8 times 8 minus 8t plus, or rather minus 2 times, insert the z, 9 minus 2t. All of that is equal to minus 6. Thankfully, we worked that out. All right. So, 28 minus 64 minus 18 plus parentheses 28 plus 64 plus 4 times t is equal to minus 6, which gives me 34? No, 34. I don't trust me for this. Solve this for t. 74, 82. What's this simplify to? Negative 54 plus what? What's this? This is 68 plus 28, which is 88 plus 8, which is 96t. So this gives us t is equal to, if I haven't made a mistake, 48 divided by, no way. That's actually pretty. Whoa, I just made this stuff up, guys. T is 1/2. Oh, that's weird. Now that doesn't, how do you find the point then? N of 1/2, that's actually the point we're looking for, right? So N of 1/2 is what? It's 7. Oh my goodness, it works out to an integer triple? No way. Oh, that is, I can't make this problem up for a test. 9, 4, 8. Yeah, that's the closest point on the plane to Bob. Seriously, when I make these up for homework, they come out to awful fractions. You probably have one in your homework that will come out to hideous fractions. You don't understand how lucky this is, what just happened. It's like writing down a circuit and coming out with like currents that are milliamps, like integer milliamps. I had that happen once. But. All right, I sense it is 5. Tomorrow, we have most of the time just to talk about homework. I think I've covered all the theory I need to this week. Tomorrow we have completely open to any questions you have about the mission. Use your time wisely.